Good morning, everyone, and welcome. Today, I am excited to present to you a topic that is crucial for maintaining the efficiency and longevity of our equipment. The title of our presentation is Checklist for Preventive Maintenance, and it is designed to help us stay ahead of potential issues. Over the next few minutes, we'll explore key strategies and steps involved in effective preventive maintenance. So, let's get started and discover how we can keep our systems running smoothly and reliably. Welcome to our discussion on preventive maintenance in pharmaceutical manufacturing and packaging. Preventive maintenance, or PM, is all about planning and systematically maintaining equipment before issues arise. The main goal is to prevent unexpected breakdowns, which can disrupt production and compromise product quality. By implementing PM, we can ensure equipment performs consistently and meets strict regulatory standards. A key purpose of PM is to minimize unplanned equipment downtime, keeping our operations running smoothly. It also helps us maintain high product quality, ensuring compliance with good manufacturing practices, or GMP. Another important benefit is extending the lifespan of our equipment, saving costs in the long run. Plus, PM improves operational efficiency and safety, creating a safer environment for everyone involved. Now, where does this apply? It covers manufacturing equipment like mixers, granulators, reactors, and more. It also includes packaging machines such as blister packers, bottle fillers, labelers, and cartoners. And we shouldn't forget utilities and support systems, things like HVAC, compressed air, and water systems that keep everything running smoothly. All of these components benefit from preventive maintenance because it keeps the entire production process reliable and compliant. So, in essence, PM is a crucial part of ensuring quality, safety, and efficiency throughout our pharmaceutical manufacturing and packaging operations. Let's take a closer look at some of the key GMP and compliance requirements that are essential for maintaining quality and integrity in our operations. First, equipment qualification status, including IQ, OQ, and PQ, must always be verified. This means confirming that our equipment is installed correctly, functions as intended, and performs consistently through validated processes. Next, calibration status is critical. It's important that our instruments stay within their valid calibration periods to ensure accurate measurements. Moving on, maintenance logs should always be updated and reviewed regularly to keep track of any repairs or inspections, helping us prevent issues before they arise. Standard operating procedures, or SOPs, must be readily available and strictly followed to maintain consistency in our processes. Change control procedures are also vital. They ensure any modifications are properly documented, reviewed, and approved to avoid unintended impacts. Finally, documenting and investigating deviations is crucial. When something doesn't go as planned, thorough documentation and investigation help us identify root causes and prevent recurrence. Overall, these points are interconnected. They form the backbone of a compliant and quality-driven environment, reinforcing the importance of diligence in every step of our processes. Now, let's talk about the production equipment we use, including granulators, reactors, blenders, tablet presses, and coating machines. It's essential to regularly check for cross-contamination risks between these pieces of equipment to ensure product purity and safety. Next, we need to inspect all contact parts, especially those made from stainless steel 316 or 316L, because these surfaces are critical for maintaining hygiene and preventing contamination. Verifying proper cleaning procedures, whether through CIP or SIP systems, is also key. This ensures that residues are effectively removed between batches. Additionally, don't forget to lubricate the non-contact mechanical parts. Proper lubrication helps keep equipment running smoothly and reduces downtime. It's equally important to check seals, gaskets, and valves for signs of wear or damage, as these components are vital for maintaining the integrity of the process environment. Lastly, we need to inspect agitators and assess mixing efficiency to confirm that our blending processes are consistent and effective. All of these steps tie back to our overall goal, maintaining high quality and safety standards throughout production. Regular maintenance and inspections like these are fundamental to achieving that. Now, let's take a closer look at the HVAC system and clean room considerations. First, we perform the HEPA filter integrity test, such as the PAO or DOP test, to ensure that the filters are effectively trapping particles and maintaining the cleanliness levels we require. Next, we check the airflow velocity and the number of air changes per hour, or ACH, to confirm that the air is circulating properly and constantly refreshing the environment. We also monitor the differential pressure between clean rooms, which is crucial to prevent contaminated air from entering controlled spaces. Temperature and humidity are kept within strict limits, as variations can impact product quality and environmental stability. Duct cleaning and inspection are essential to remove any buildup or blockages that could compromise airflow or cleanliness. Lastly, verifying the alarm systems helps us respond quickly to any deviations or issues that might arise. Moving on to the clean room and facility itself, we need to ensure the structural integrity of walls, floors, and ceilings, no cracks or peeling, since these can harbor contaminants. Pass boxes and airlocks must be functioning properly to facilitate contamination-free material transfer. The cleanroom classification, such as ISO class standards, needs to be maintained consistently to ensure compliance. Lighting and pest control measures are also checked regularly, because both can impact cleanliness and sterility. Finally, environmental monitoring compliance is vital. It helps us verify that all environmental parameters are within acceptable limits, ensuring the overall integrity and safety of the cleanroom environment. All these elements are interconnected, and together, they support the overarching goal of maintaining a controlled, contamination-free environment. Let's talk about water systems, specifically purified water and water for injection, or WFI. These are critical components in our pharmaceutical processes, and maintaining their quality is essential. First, we regularly check conductivity and total organic carbon, or TOC, levels. These tests help us ensure that the water remains pure and free from contaminants that could compromise product safety. Conductivity indicates the presence of inorganic ions, while TOC measures organic impurities. Next, microbial limits testing is vital. We need to confirm that microbial levels stay within acceptable limits to prevent any microbial contamination that could affect the efficacy or safety of the final product. Sanitization of water loops is another key point. Regular cleaning and sanitizing prevent microbial buildup and biofilm formation, which can be tricky to detect but pose significant risks. Speaking of biofilms, we also conduct pipeline inspections, specifically looking for any signs of biofilm formation. Biofilms can harbor bacteria and other microbes, making them a serious concern in water systems. Finally, we focus on storage tank integrity. Ensuring tanks are properly maintained and free from leaks or contamination is fundamental to keeping the entire water system safe and effective. All of these steps tie back to our overall goal, keeping our water systems pristine so that the products we deliver are safe, effective, and of the highest quality. Let's take a closer look at the electrical systems today. First, we need to ensure that panel inspections and cleaning are regularly carried out to maintain safety and efficiency. Proper earthing or grounding verification is also crucial, as it helps prevent electrical shocks and protects equipment from faults. Next, we check the UPS and backup systems to guarantee they will perform reliably during power outages. Cable insulation and load testing are essential too, as they help identify potential failures before they happen. Moving on to utility systems, the quality of compressed air must be oil-free and moisture-free to avoid contamination that could affect sensitive processes. Nitrogen and other gas systems need to be verified for purity, ensuring they meet the necessary specifications for safe and effective use. Steam quality is equally important. We perform clean steam validation to confirm it's free from contaminants, which is vital for many manufacturing processes. We also inspect boilers and chillers regularly to make sure they operate efficiently and safely. And finally, backup power systems, such as diesel generator sets, must be tested and maintained so they can reliably provide power when needed. All these points are interconnected. They form the backbone of a safe, reliable, and compliant facility. Keeping these systems in top condition supports overall operational integrity and safety. Now, let's take a closer look at laboratory equipment, including HPLC, GC, UV, and dissolution apparatus. These instruments are essential for accurate analysis, but their reliability depends on proper maintenance and calibration. That's why calibration and system suitability tests are so critical. They ensure our equipment is functioning correctly before starting any analysis. Regular preventive servicing, scheduled according to manufacturer recommendations, helps prevent unexpected failures and keeps everything running smoothly. It's also important to routinely check components like detectors, pumps, and columns. They're the core of our analytical accuracy. Another key aspect is ensuring our software complies with 21 CFR Part 11 standards, which govern electronic records and signatures, maintaining data integrity and regulatory compliance. Lastly, we need to verify that standard reference materials remain valid for our testing purposes, as their accuracy directly impacts the quality of our results. Overall, maintaining and verifying our laboratory equipment is fundamental to producing reliable, compliant, and high-quality data that supports our overall quality assurance process. Let's now turn our attention to safety and EHS, environment, health, and safety, since these are critical to maintaining a secure workplace. First, we have emergency showers and eye wash stations, which are essential in case of chemical splashes or other accidents. It's vital that these stations are easily accessible and regularly maintained to ensure they work when needed. Next, fire extinguishers and hydrant systems play a key role in firefighting efforts. Regular checks and proper placement are crucial so that they can be used effectively in emergencies. Moving on, hazard zone compliance, such as ATEX zones if applicable, is about making sure we identify and manage areas where explosive atmospheres might develop, keeping everyone safe from potential explosions. PPE, or personal protective equipment, must always be available and in good condition. This includes helmets, gloves, masks, and more. It's our frontline defense against workplace hazards. Lastly, spill control systems are designed to contain and manage any accidental leaks or spills, preventing environmental contamination and reducing health risks. All these elements are interconnected and form the backbone of a strong safety culture. By paying close attention to these areas, we not only protect our team, but also demonstrate our commitment to responsible operations. Let's now discuss the importance of cleaning and sanitation in our process. First, we need to consider the cleaning validation status. This means ensuring that our cleaning procedures are validated and consistently effective. It's crucial because it helps us confirm that residues are removed properly and our cleaning process is reliable. Next, residues must be within acceptable criteria. That's a key point. Residue limits are set to ensure safety and quality, preventing any contamination or cross-reactivity. Staying within these limits is essential for maintaining product integrity. We also need to verify and label our cleaning agents. Proper verification ensures that the cleaning agents are effective and suitable for use. Labeling provides clear instructions and traceability, which is vital for compliance and safety. Finally, we must follow the designated cleaning frequency for our equipment. Regular cleaning schedules help prevent the buildup of residues and microbial contamination. Consistency here supports overall hygiene and product quality. All of these points connect back to our overall goal of maintaining a safe, compliant, and efficient manufacturing process. Proper cleaning and sanitation are fundamental to achieving those standards. Let's start by discussing the importance of documentation and data integrity. Maintaining accurate and complete records is essential, and this includes adhering to the ALCOA Plus principles, which ensure data is attributable, legible, contemporaneous, original, accurate, and also complete, consistent, enduring, and available. Regularly reviewing audit trails helps us verify that data hasn't been altered improperly, providing transparency and accountability. It's equally important to keep logbooks properly filled out, ensuring all entries are clear and traceable. And of course, electronic data backup and security measures are critical to protect our data from loss or unauthorized access. Now, moving on to maintenance, especially the frequency-based approach. Daily tasks include environmental monitoring, checking temperature, humidity, and cleanliness to ensure conditions stay within set parameters. We also perform visual checks on equipment to catch any issues early. Weekly, we focus on cleaning filters and conducting utility checks to maintain optimal operation. Monthly, calibration verification is key to ensure our instruments remain accurate, along with HVAC performance checks to maintain proper environmental conditions. And on an annual basis, we undertake requalification activities such as IQ, OQ, and PQ, which validate that equipment and processes continue to meet specifications. Preventive overhauls are also scheduled to address potential issues before they cause problems. All these activities are interconnected, forming a comprehensive approach to maintaining data integrity and operational reliability, which ultimately supports the overall quality and compliance of our process. Let's take a moment to look at this example checklist. What we're seeing here are the key steps or considerations we want to keep in mind during our process. Each item on this list represents a crucial point that helps ensure we stay on track and meet our objectives. Notice how the checklist connects to the overall theme of thorough preparation and systematic approach. By following these points, we reinforce consistency and quality in our work. It's important to remember that checklists like this serve as practical tools. They keep us organized and help us avoid overlooking vital details. So, when applying this concept, think of the checklist as a roadmap guiding us through each phase, ensuring nothing gets missed along the way. This example underscores the value of having clear, actionable steps that support our larger goals. If you need any further support or have questions, please don't hesitate to reach out. We're here to help you succeed. Thank you so much for your time and attention today.